We have seen that a vector space can have more than one basis. For example, this set 1001 is a basis for R2. But so is this. The first one is the standard basis, and the second one is a non-standard basis. There could be many non-standard bases. Let B be the standard basis, and let B prime be the non-standard basis, we want to be able to represent a vector in R2 given in terms of B as a vector in terms of B prime, and vice versa. In other words, we want to be able to change the basis. For example, let X be given by 4, 15. Four 15 can be written as 4 times 10 plus 15 times 01. So the coordinates for X relative to B are 4 and 15. So the coordinate matrix for X relative to B is given by 4, 15. We want to find the coordinates for X relative to B prime. Okay, so we want 415 to be equal to C1 times the first vector plus C2 times the second vector. So that implies that 415 is equal to this vector. And setting the components equal to each other, we get this. So we get a system of equations, and if we try to solve this, let's do -2 times the first equation plus the second equation. And so we get C2 equals to 1 and C1 is equal to 6. Okay, so 415 is equal to 6 times the first vector plus 1 times the second vector. Okay, so the coordinates for x relative to b prime are 6 and 1. So the coordinate matrix for x relative to b prime is given by 6, 1. In our example, we changed the basis from b to b prime for the vector x equals to 4, 15. We want to be able to do this for any vector in R2. But more generally, if V is an n-dimensional vector space, so V is an n-dimensional vector space, and B and B prime are two bases for V. Okay, so if V is a vector space and B prime are bases for V, then we want to be able to change the basis from B to B prime for any vector in V. It turns out that there is a way to do this. There is a matrix P called the transition matrix. From the basis B to the basis B prime. Such that P times the coordinate matrix for x relative to B is equal to the coordinate matrix for x relative to B prime. If we're given the coordinate matrix for x relative to B, we can simply multiply by the transition matrix P, and the result will be the coordinate matrix for x relative to B prime. There is a procedure for finding the transition matrix P. Form the augmented matrix B prime B and perform Gauss-Jordan elimination. To get the matrix like this. So you'll have the identity, and whatever is on the right hand side is P.